Hey all, welcome to the session. Today we're going to talk about how we can unlock the true potential of data and AI using fully orchestrated and industry-specific that are, healthcare lakehouses or platforms. My name is Harish Veldandi, and I'm the founder of Percept Health. We are a startup that is focused on healthcare data solutions. I'm also the author of The Hidden Crisis. I have an MBA from University of Cambridge, and I worked at companies like Microsoft, Epic, and Orion Health, and some other great leading roles at health systems, Advocate Health, and Kaiser Permanente, and so on and so forth. I'm a true believer of the potential of truly liquid healthcare data, and that's what Databricks is actually enabling us to do it. Just a bit more about Percept Health. We are the outcomes partners for healthcare data journey. We work with a lot of health systems, ACOs and CINs, and we do everything healthcare data and AI, but primarily we also build purpose-specific platforms and solutions. Our team, we have experience of helping millions of lives and thousands of providers. We also work in fee-for-service and value-based care worlds, again, CINs and ACOs, health systems, health payers, and payer operators, and so forth. So today, unfortunately, my client partner is not here, the founder and CEO of Doral Health and Wellness, but we're going to talk about what we did at Doral. Doral is what I call a mini health system, and they serve patients in New York boroughs, primarily serving brown and black communities. And they're actually an interesting story because during the COVID times, they were one of the few organizations there who would administer COVID vaccinations for homebound patients. So we worked with this client for the last 1 year or so, and they're a very tech-enabled organization, but they did not have any of their data workloads in the cloud. And so we actually did double hop or triple hop, and I'll talk about what I mean by that. But a lot of good stuff there. And like I said, they have a mini health system type setup, and especially in the middle, if you look at it, they're actually building something called Road L, and it is, think of it more like a Uber for healthcare. They're starting with New York State, and they want to expand it to the other states. But they are essentially building a multi-sided platform where they would have the field clinicians, nurse practitioners or nurses or whatnot, that are onboarded on the platform, and any patients that would like to have some kind of a home-based visit, they could actually log on to the app and then, find the nearest nurse provider or field clinician, and then book a service, and then the field clinician would go there and then provide the service. So that is a cool concept, and then eventually they want to expand it to the multiple states. They have a primary care practice, they have multi-specialty, they have an adult daycare center, they have a home health center, and a dialysis center. So they're pretty unique in that combination, and for that size. And they're also heavily invested in technology. So they have another brand called Health Connect. And so we, Percept Health, we worked with them to build a fully orchestrated healthcare data platform. So we're going to talk deeper into some of this stuff, and then how we did it. But before I do that, I just wanted to throw in this night vision diagram from Databricks. Actually, it nicely fits into what we did. All the way at the bottom, we have sorry, I can't actually focus on it. Right here, all kinds of data, and then on top of that, the data lake architecture with the Unity catalog supporting, different kinds of use cases, whether they are the yesteryear, analytics or the modern day Mosaic AI type solutions. And we did pretty much all of these, and then I'll tell you exactly what we did. This is kind of like a DOS statement, right? Data analytics platform is the foundation, but especially so for healthcare industry because quality data is extremely important. During my beginning days of Epic, I learned, there are two most important things about healthcare industry is number one, patient safety, and number two, patient privacy. As the custodians of the data, we always have to keep that in mind. And so having a solid platform where those are taken care of is extremely fundamental and foundation to many use cases that we want to enable. So what did we do? So we did build a custom data intelligence platform from the ground up. And we brought in the data from multiple systems, almost 15 to 16 different sources. We brought in the data from payers, ACOs, CINs. So this particular practice group has a relationship with multiple providers there in New York and multiple payers. And we brought in the data from HIE as well. As many of you would be in the healthcare world, it's basically health information exchange. So it's called HealthX in New York region. So we brought in the admission, discharge, and transfer data. And then, like I said, Doral has a home health business. So they're also on a HHA platform. It's called HHA Exchange. And so we brought in the data from there as well. And then they also do care management for thousands of patients. And so they have a separate care management system. So we brought in the data from there. And then about 2,000 of those patients are actually on medical devices, remote patient monitoring. So we brought in the data from there as well. And then internally, they have two EMRs. One is eClinicalWorks, the other one is Athena Health. So we brought in the data from both of them. And then some other HR and Active Directory and patient engagement system. They have Zoho CRM, and so we brought the data from there as well. And again, pretty typical of the Medallion architecture that we followed. I don't know if anybody attended the previous session there that talked about the immunization registry right next door, but we followed almost similar approach here. Bronze, and then silver, and then the gold zone, and then before the data actually goes into gold zone, we did EMPI, the custom enterprise master person index algorithm for this customer, because again, we have unique data, and we needed to marry Harish from one stream to Harish from another stream, and so on and so forth, right? And then again, Apache Spark, clusters, and Databricks, that is the foundation. Eventually, we pushed the data into the two more zones. We call them analytics zone, and the other one is the AI zone. And so analytics zone was serving the Power BI type insights. And then AI zone is where we built the custom ML algorithm, and then also we started using the same zone for one of the generative AI use cases. So this is how the end-to-end orchestrated jobs look like. I just want you to take a note of a couple of things here. I don't know if it is too clear there. There are two workflows that are actually specific to ML risk stratification algorithm. One is the end-to-end algorithm, which actually that's where we build we run the experiments and we auto register the best performing algorithm. But the other one is just the inference. So one is actually scheduled, the other one is not scheduled, it is paused because we don't have to run this ML algorithm, end-to-end algorithm all the time. So that's one thing. I'm gonna talk a little bit more down the line, but the other thing that I would like you to notice is the word itself, which is the stream. I mean, a lot of us actually are used to calling data pipelines, but in the full orchestration, we actually worked with DevOps engineers. So we really treated this as a software product. And then the DevOps engineers started calling everything as like their pipelines, DevOps pipelines. And we started calling them data pipelines. And like everybody was like, do you mean data pipeline? Did you mean DevOps pipeline? So we stopped using the pipeline word and we started calling it streams. All the streams would actually push the data into the data lake. But every stream would have their own jobs and whatnot, right? So this is just one example. This is the ECW stream. So ECW, they have a reporting database, our nightly database, where we actually pull all the data. So first the data actually, let me go back there. First the data lands in the landing zone, as you could actually see the name of it, and then from there landing zone to staging zone, and then from staging to enriched. And then from there we actually did the work of, this is where the EMP algorithms, so on a nightly basis, we would essentially look at all the demographics changes for all the patients in the system, but also any new patients that are coming in, and then we would give them, or we would relink or delink any of the, the records coming from different streams, and then that's where we actually populate the data into the gold zone. First, we populate the demographics, and then from there, we actually populate the remaining all the zones into the gold tables. And again, if anybody wants to know more details about how we did this, it's actually more complex than it seems, especially these steps. But I'm happy to actually give you any pointers as well. And we repeated that for all the other streams. And so this is where the Azure DevOps integration comes into the picture. It is fully orchestrated in the sense, we actually use the Databricks Metastore and then Unity Catalog as the foundation. And then we actually thought of using 3 different workspaces, one for dev, one for test, and one for prod. But in the end, to save some money for the customer, we only ended up using dev and prod. And then what we did is essentially Azure DevOps Git, as soon as you create a SQL code change or Python code change, it would go into the Git, and then the Git would automatically copy the data into the dev environment, and then all of our streams actually run. And then if they run okay, then with one manual trigger, everything goes to the prod. But the schema and the definitions and the tables and everything are identical in both dev and prod environment. And then again, so some of these artifacts are actually just shown here, but it is fully orchestrated and then very well integrated with the DevOps. And that is one of the biggest takeaways that I want you to give away, which is treat the data intelligence platform like a product, like a software product, and then make sure that you start with the DevOps. Obviously, modern day, the DevSecOps and everything comes into the picture, but when you do that, then everything actually starts flowing in. So this is where I call double hop or triple hop strategy, especially for healthcare industry, for right reasons, because we are the custodians of one of the most important data sets out there, and some of the data sets are actually the most private in the day-to-day workings, right? So we got to respect that, and so that's why healthcare industry is always like a follower, not a trendsetter, especially when it comes to data. So I know lots of my customers, at least half of the customers, they do not have even single database on the cloud unless they are working with some software vendors and the vendors actually manage everything in the cloud, right? So they themselves are not actually in the cloud. But I think the time has come. The cloud has existed for 10 years. Generative AI actually changed the game. The likes of Databricks are enabling it, but so this is where I call my customers and I tell my customers, hey, you can actually leapfrog into the cloud, so that's the first hop, but then also you can do a next hop, which is you can do the traditional machine learning custom algorithms that everybody else is doing, you can actually do it. So that's the second hop, but the third hop is you can also do the generative AI. We all learned about prompt engineering, the RAG, the fine-tuning and everything. Of course, not every organization is ready to do the complete pre-trained models, but at least you can do the prompt engineering or the RAG models with the data that you got. So essentially you can do 3 hops in one go. In fact, you can learn from everybody else's mistakes, right? And for the last 10 years, and if you are holding, this is the time to move because this is what will happen, right? This is where the world will go to. So with that foundation set up, with the data that we are getting from almost 16 different sources for 50,000 patients, we had unique data that is really specific to Doral Health and Wellness. And so what did we do? We did the second hop. The second hop is doing a custom risk stratification algorithm for their care managers. Again, so this is these days so simple. I'm not a data scientist by any means, and there must be a lot of data scientists here, and then I give it to them, but unfortunately, or fortunately, right, for rest of us, it is becoming easier and easier to do a machine learning custom algorithms, right? So this is a classification algorithm. We didn't try to do a regression algorithm. You could have done a regression algorithm, but there are, again, those who are very much into the pair and HCC algorithms and whatnot. There exists a lot of algorithms like CMS HCC algorithm, HS HCC algorithm. We didn't want to reinvent the wheel, but we wanted to actually come up with our own custom classification algorithm with 5 classifications, low, very low, and then medium, and then high and very high risk populations on a nightly basis. We wanted to do that. And so we used MLOps and AutoML from Databricks. And with the AutoML, the beauty is essentially you can run the entire experiment, the risk stratification experiment, with so much ease. So here, I show some artifacts here, some screenshot here that actually describes all the runs that we had. We chose, F1 score. We chose the best algorithm. And then, again, programmatically, all of these runs would happen within a couple of hours and whatnot. And then we would register the best algorithm, and then we would promote it to prod, and then we would infer the entire patient's classification on a nightly basis. Again, so this was easily done. We used the orchestration. We used actually workflows within Databricks, as you could see here. So the most of the work was actually spent here, which is the feature generation. So we pull the data from the gold zone. So this is the AI zone that I was talking about. And then we also load the training data set. So we got the insights from some of our care managers, and then we loaded that data, and then we would run the experiment. This entire experiment can be finished within 2 hours, or if you want to run it for a longer time, you can. And then once that is done, the registering of the model would also happen in this particular step. And then finally, the batch inference. This can be done, again, scheduled to be done at any time, but we are running it only on nightly basis right now, just to save some costs. And then every night, essentially, some of the patients would move from high to very high or medium to high, depending upon how the data is coming in. So let's say if there is a patient who had emergency departments in the last 2 days that we picked up from HIE data, then we adjusted the weightings in such a way that you would immediately be in the at least high or very high type category. And again, this is all given by our clinical team and their insights. And so about, let's say, 3 to 2% or 2 to 3% of the patients would end up in the very high category every night, and then about 10 to 15% would be around in the high category, and then the care managers can actually get to look at the very high patients on a nightly basis. So that's what we did. You don't have to actually look at this because there are on Databricks website there are far better coding examples, but I just wanted to show you a couple of things here, just code snippets. And then we did the third hop, which is the generative AI use case. To be very frank, this is not in production, so this is a proof of concept. Everything else that until I demonstrated right now, that's in production. It is working with the live data, but this one, this is just a proof of concept, and we are still determining how to actually move forward with this one. But this is a classic chatbot, very first use case that many organizations are actually attempting it. So just to take you back to Doral Health and Wellness and the uniqueness of them, remember the Doral platform that they're building, the multi-sided platform. So that's where they would onboard the field clinicians. So they have literally something called Doral Operation Center. We call them rock stars. So rock stars would answer all the questions for any of the nurses. Similar to Uber, Uber would onboard all the drivers, right? And during the onboarding process, you would have to check the driver's license. You would have to check the background. You would have to check any of the payment platform, Stripe integration and that type of stuff. And similarly here, the field clinicians, we need to make sure that their credentials are up to date, and then of course take their availability. When are they available? In what regions? What zip codes? And then also if they have any Stripe-based integrations, how they want to actually receive the money when we make the payments. So all of that is done, and so they have lots of questions, right, during the onboarding process. And so the concept here is, how do we ease the burden on the rock stars, the central team that would help all the onboarding of the field clinicians. So we use the generative AI algorithm here. So the way it would work is essentially the knowledge base articles are also pumped into the same Lakehouse, same platform that we built. And then we create the embedding vectors, and then we store the embedding vectors in the vector database. And then any field clinicians that is entering in any of the queries, then they would get converted into the embeddings, and then we do the nearest search, and then get the nearest algorithms, a couple of these articles rather, sorry. And then we feed that into a GPT algorithm, LLM algorithm, with a prompt engineering pipeline with those knowledge-based articles as the context, and then we generate the appropriate answer, and then we feed it back to the chatbot. So very simple, but this was actually done within a week, actually even less than a week, I would say. We just needed to play around, the vector search. There are multiple options these days. When we did this, I think we did it back in January of this year. The DBRX was not released, so we used actually OpenAI for the GPT LLM. We used Facebook AI similarity search algorithm, but I think now Databricks has option pretty much everywhere here, all the things, vector databases and all the options, after they acquired Mosaic AI and then tightly integrated everything, and that's the beauty of the Databricks platform. So we might actually move to all Databricks components for this particular use case, and then we would most likely push it into the production with that. Again, super simple. This is the third hop, and Doral Health and Wellness. It's a fine organization with limited resources, but we were able to actually accomplish this with ease. None of this would have been possible 5 years ago, 10 years ago, whether it is custom ML algorithms, whether it's generative AI, of course, but also even the Lakehouse platform. So with that, basically what I'm going to, well, there are a couple of code snippets, but another important takeaway, right? There are lots of healthcare platform companies, product companies that actually build another layer. So think of it as an abstraction layer, right? Databricks is here, all the way at the metal, and then the cloud, and then Databricks, and then we build on top of the Databricks, right? And then the product companies, the healthcare product companies, they build another layer on top of, underneath, it would be Databricks or one of the competitors. But in my humble opinion, Databricks actually brings in at the right abstraction layer level. We don't have to spend millions of dollars and then give away to another abstraction layer, and then they do exactly the same thing. They have a UI, they have the workflows and everything, but Databricks actually provides you with all of that. And especially if you have good enough budget, you can do everything indoor with some good data experts, somebody who would have done this before, and with your own internal expertise and then teams. So that's one of the biggest takeaways, again, is we don't have to have millions of dollars. We don't have to pay them to the product companies. And that's what we did here at Doral Health. So we got the data from 2,000 plus medical devices, 45,000 plus patients, 10 million plus records. If you look at a lot of different sources, we added 1 or 2 extra sources after the 14 sources since I prepared these slides a couple months ago. So some of the use cases that we are enabling, like I said, the risk stratification algorithm is for care managers. They wanted to look at essentially our predictor risk category, and then also mix it up with some of the other analytic zone markers, patient markers. For example, who had the abnormal values. If you have a CHF patient and they have a weight scale at home, and if the weight went up by 3-4 pounds overnight, then that's actually an indication of some kind of a trouble, and then it's better to intervene, right? So those are the types of the markers that we were able to bring in. And then also, if you could see, they wanted a very simple screen here with these 24-hour and 48-hour and 72-hour acute and ER visits. So all of this data, we are getting the ADT data from the HIE, and then we were able to actually show these markers right around here. And then if you, depending upon how you choose the predictor risk score, and then whether they are on a certain program, care management program, what facility, and then what abnormal values. And then if they have any upcoming visits, in Athena or in ECW, these two EMRs, for I think statutory reason, they had two different EMRs. But essentially they can look into the future, who's actually coming on to see my providers, but also who had any acute and ER visits. And this, the moment you apply, let's say, very high risk category there, this would reduce to 100 or 200 patients. In fact, it would even further reduce to just about a handful of patients that they need to immediately act upon. They would call them, and then they would, if they don't have any visit, they would book an appointment and say, hey, look, your weight is going up, you're a CHF patient, can you come and see us? Because you could be in trouble. So that's the first use case we actually enabled. So this is the other Uber patient search with lots of data. They intentionally wanted this in the sense that they wanted to apply lots of combinations here of the patient markers. Previously, what they used to have is one report for one particular use case and another report for a use case, and so on and so forth. They would have 20 different reports, but this single Power BI screen dashboard with all of these markers enable them to avoid all those reports, and then they can pick and choose different combinations, and they can get to their patient list super quick. So this is another use case that we are actually enabling. And this is primarily used by the analysts as opposed to the end users, because they are the gatekeepers to the end users, like the clinicians and the care managers. And then some of the other use cases that we are, in the works in actually implementing is risk adjustment. Again, those from especially MA, and then also health systems would know the importance of risk adjustment. It is extremely important for us to accurately capture the risk profile of every single patient, because if you are an MA payer, you would get appropriate and right dollars from CMS and whatnot. So we are actually helping them with that risk adjustment use case. Quality improvement, obviously that's another beast, and so this is where the product companies would actually come in, right? You might not have the dollars and resources to build a quality engine from the ground up and then maintain it as the HEDIS specs change on a yearly basis, but you could always identify some simple quality gaps based reports. So that's what we're actually doing it. You could also do patient engagement, and then we started playing around with the suspect diagnoses using natural language processing and using generative AI. Obviously, if you use any GPT models, let's say OpenAI, and then give them a medical note and then say, okay, can you predict some ICD-10 codes? It can do that, but it can also have hallucinate, and it can also not actually give you the right appropriate input. So that's where fine-tuned models actually come into the picture. So we haven't started the journey, but that is our next step, which is to take one of the Hugging Face models and then fine-tune them with the data that we got using the medical text and everything, and then hopefully generate the ICD-10 codes. There are some other Databricks partners that are already doing this. For example, John Snow Labs is extremely experienced in this for the last few years, and they have tons of algorithms and options. And again, you don't have to build everything from scratch, and you don't have to buy all the time. You can actually do some kind of a assemble approach. So that's where the John Snow Labs type would come into the picture. And then clinical summary. So this is another use case that is quite possible for us, which is we have the data from all these sources for 50,000 patients. So our idea is to build a simple one-page clinical summary that would actually be almost like OpenAI output, right? So you ask, okay, give me the patient summary, and then it would just look at the very latest data as of this moment, and then give the full clinical summary context that the clinicians would be able to use, and then make real-time decisions. But those are all in the works. The top two are what we put them in the production at the moment. Again, so just tied everything back to here. So we actually used a lot of logs and text, structured and semi-structured data. We don't have audio and video and images. Just imagine where the world is moving towards, where the physicians have these conversations with the patients, and we would record those conversations, and then we would actually pump those into those audio files into the same platform, and then we can actually make sense out of that. So that's the futuristic vision, but again, Databricks actually supports all of that. And then we talked about the workflows. We talked about the AI scenarios, the custom ML algorithm, and then Mosaic AI, and then we have some live tables, although we are not really using them as much. But yeah, so this is the overall vision that we are following. Again, so just I wanted to repeat one more time. We don't have to give away millions of dollars to rigid platform companies. You can build your own. So just to take you back to that entire project, it was primarily around 7 to 8 month implementation until the generative AI use case. And we did it with a team of 5 to 6 people. And yeah, it was done, essentially. But we, of course, brought in a lot of healthcare expertise, especially the EMP algorithm. We have one of the best healthcare architects as such, data architects that was able to build that EMP algorithm. But you can also do this, essentially within a quarter to 2 to 3 quarters. That's where the world is moving towards. So some of the challenges and tips and learnings. Again, so healthcare data domain knowledge is irreplaceable. And most of the vendors, if you are working with any vendor, like a middle vendor I'm talking about, not just Databricks, right? On top of that, if you are working with a product platform company, healthcare product company, more often than not, they actually rely on your expertise, your team's expertise, if you are a healthcare organization, if you are a payer, if you are a provider company, to help them address any of the questions they might have. But you already have that domain knowledge, and then if so, essentially just leverage that. That is irreplaceable is what I believe. And then think DevOps, I think we talked about this. The full orchestration and treating the platform as a product is extremely important. Start with the security framework, patient safety and patient privacy is extremely important. But also everything becomes easier the moment you have the environment set up, and then people start coding in, whether it's SQL script, whether it's Python script or anything, and then automatically the code is checked in, and then some of the tests run, and then you move the data, the code to the prod. All of that is possible. So definitely think DevOps first. And then the streams and pipelines, we talked about that. That's where actually just our own experience, finalize the terminology. It could get mixed up in the middle. And then also the way we named our zones, right? We were thinking about lots of different, bronze, silver, what do we call them? There was actually some, pretty good contentious. Oh, some people wanted to actually call it bronze. Some people wanted to call it something. But we landed it landing as the landing zone, and then staging as the staging zone, which is kind of bronze, and then enriched as the silver layer, basically the cleansing of the data and then enrichment of the data. And then ironically, we kept the gold as the gold because we wanted to keep one of the zones as like an important zone that doesn't get, doesn't get used in a bad way. So that's why we used gold. And then we also ended up creating 2 more zones, which are like analytics zone and then AI zone. And so these are all the end-to-end zoning. And then finally, we also had what we call backup zone. So what happens is when the data is either we pull in something is pushed into the landing zone, after the data is processed and then put it into the staging zone, we would make an immediate backup, and then we would put it in the backup zone, because if you want to replay any of this in the future, we can actually do that. So we were able to use that. So the terminology like the streams and the zones and the pipelines, again, just to have a good session, and then you can pick and choose, and then from there everything will be easy. Unity catalog and schemas, we talked about it. It's very well possible, like you don't have to do anything special to prod. You can do everything that you're doing in prod in dev as is, and then when the code works, somebody just needs to click on a button, it just has to go to prod, and then it should just work. With the initial catalog concept, and then Unity catalog, and then schema names, if you appropriately design the table names and the schema names and everything, you can do any number of environments, dev, test, and prod, and whatnot. Permissions and service principals, we had a couple of hiccups. We needed to make sure the right people had right permissions. Only certain people would approve the code to move to prod. They would do manual check and whatnot. So that's where these permissions and service principals come into the picture. Workflows management, they are your friends. Workflows are your friends. I think they may look like just a couple of boxes here and there, but each of those have some 2,000, 3,000 line codes it can take. But at the same time, you can actually componentize in such a way that you have, for the same ML risk stratification workflow, we had actually two different workflows. One is the inference only, and the other one is the full end-to-end, running the experiment and registering and then doing the inference. So managing the workflows, I think that's extremely important. And then AutoML orchestration, like I said, I never thought, so I think almost like 5 years ago, I worked with a data scientist to design some kind of a ML algorithm, but back then it was very, very difficult. We had to do everything manually. I mean, the fact that we were able to just quickly run, within 2 hours, 200 runs, and then get F1 scores available for, some logistic regression, some other, types of the algorithms, and then it's automatically telling you, okay, this is the best performing algorithm, push it to the prod, and then you can do that, and then it is done. I mean, I just did not envision that, we would get to that world so quickly, but we are there. So that's I think somebody was asking what is my favorite feature. That is definitely my favorite feature in terms of, what we can do with machine learning on top of the Databricks platforms. Yeah.